Okay, with this video we're going to start off with finding the missing angle, and that's also used with trig. So finding the missing angle, and we talked about a definition in class, and that definition was using an inverse trig function. Using an inverse trig function, and those functions are sine of -1, cosine of -1, and tan of -1. Using those functions, you can determine an unknown angle. Sorry, this takes a while to write. Unknown angle. Okay, so that is the second button on your calculator. Use second button in any of the cosine, sine, or tan, and that will give you the inverse. Okay, so you're always going to use the inverse button to find an angle. Alright, so we'll just go straight into some examples. So for the first example, if I have this triangle, I'm missing my angle, so I'll use theta. And for this side is 10 and the hypotenuse is 12. So you need to look at this triangle and visualize what is happening as you're looking for theta, that angle that has that funny little zero on it, that's called theta. What are those other two pieces in the triangle that are related to that angle? Or how do they relate to that angle? So as I look at it, the one that's across from the hypotenuse, or across from the 90 degrees, is always my hypotenuse. And the one that sits farthest away from the angle I'm looking for is the opposite. So this is my opposite. So then I have to think which one of my trig functions uses opposite. Cosine comes around here, tangent tripping on apples. Which one of those three, out of those three, uses opposite and hypotenuse? There's always only going to be one that works. So I have sine of theta is equal to my opposite over my hypotenuse. Okay, so to find the angle, it is nothing more than, since I'm using sine, I will use the sine inverse of 10 over 12 and get my answer. So I'm going to type this into my calculator. Second sine 10 divide 12, and that gives me an angle of 56 degrees. I'm going to use it to the whole number. So 56 degrees. So that means now I have found my angle of 56 degrees. Great. So if I found sine of 56, we've been practicing what the complement to sine of 56 would be. So half of my triangle, or I should say the corner of my triangle, is 90 degrees. That means the other two angles are 90 degrees added together. They are called complements. Okay, so with the complement angles, that means they are equal to 90 degrees. And when that happens, you have two things that are happening. You can use sine and cosine are always complements of each other. So if I have sine of 56, I know that the other half of this equation would be cosine, and I just have to realize cosine of what. So if it's sine of 56, what is the measurement of that opposite angle? How many degrees is that opposite angle? And when you put that in your calculator, 90 minus 56, you get 34. So that means this angle right here is 34 degrees. So sine of 56 is equal to cosine of 34. And if you put those in your calculator, you're going to get sine of 56 is equal to 0.8 and if I put it in my calculator, cosine of 34, you should get 0.8, and you do. So they're equal to each other, and they're called complements of each other. Now, if I'd have said, okay, so how about if I have cosine of 56, what is the complement to that? You should be saying sine, because cosine and sine are always the complement of 34. Okay, so those are complements, and this is how to find a missing angle. All right, let's do another example. If I have a triangle such as this, and I give you an x, and I say that this is 12 and this is 8. So I want to find the angle that goes to these two pieces. Now what I'm looking at is I'm trying to find something on the inside of my triangle. That means use the inverse buttons. Use inverse when on the inside of your triangle. Alright, so if I'm looking at this angle, what does that 12 and 8 have to do with that angle? What relationship? Well, that 12 is a lot closer to that angle than that 8 is, so 12 is adjacent, and the 8 would be opposite. So which function works with opposite and adjacent? And that is tangent. So tan of x is equal to tripping on apples, so 8 over 12. I'm looking for that angle, so I'm going to use the inverse button. Tan of -1, 8 over 12. And all I have to do is plug that into my calculator. So when I do that, I hit the second button, the tan button, I type in 8, the divide button, and 12, and hit enter. And I get that that angle is 33.7. So I'm just going to round it to 33 degrees. So my missing angle right here is 33 degrees. So then if that's 33 degrees, I can take 90 and subtract it from 33, and I'm going to get, let's see, what do I get? 90 minus 33, I get 57. I was going to say 67, and I knew that wasn't right. 57 degrees. So this angle right here is 57 degrees. So if I asked you again, if I had sine of 57, and I say, what is the complement to sine of 57? You should be able to tell me cosine of 33. And that would give you your complements. And that truly is as hard as it gets for finding the missing angle. Now, we haven't talked about this yet, but I'm going to go ahead and talk about it on this video. And what we need to talk about is angle of elevation and angle of depression. So an angle of elevation is when you're looking up at something. Okay? The definition is an angle formed by a horizontal line, an angle formed by a horizontal line and the line of sight. Line of sight to an object above the line. To an object above the horizontal line. So that would be me just standing. If I was standing here and I'm looking up at something, my horizontal line, or my line of sight, is a straight line. But if I look up, this is an angle of elevation. Okay? Me looking up, that's an angle of elevation. Now there's something called an angle of depression, and it's just the opposite. Angle of depression. And once again, that's an angle formed by a horizontal line and the line of sight to an object below the horizontal line. So this is an angle of depression. If I write it all out again, an angle formed by a horizontal line. Formed by a horizontal line in the line of sight to an object below. That horizontal line. So a picture, this would be me maybe looking down at my shoes. So here's my horizontal line, but I'm looking down at something. So this is called an angle of depression. When you're looking down, okay? When you look down, that's an angle of depression. Now this plays into effect when we have word problems. So when I'm looking at an angle of depression, I am, what do you notice about these pictures? Let me draw another picture so you can see what the triangles look like. So if I have a triangle and maybe I have an airplane up here, no fear of laughing at my drawings, right? It has a horizontal line of this, and it is 3,000 feet above the earth. It's flying around, and this is the airport. Whoops. And the pilot wants to know the distance from where it's at to the airport. So it wants to know this distance right here. So what it's doing, it's looking down. It's giving you, this is an angle of depression. And actually in this problem, it tells you that the angle of depression is 3 degrees. So that airplane is looking down at the airport, so that would be an angle of depression. Now if you think back to when we did transversals that cut two parallel lines, that angle of depression and the angle of elevation are actually equal to each other. So my angle of depression is up there where the airplane is looking down, but people at the airport would have an angle of elevation. If they're looking up at the airplane, that's going to be an angle of elevation. If the depression looking down is 3 degrees, then looking up is also 3 degrees. So I can find the distance from that airplane, well, from the spot at which the airplane is from here, which is from here to the airport, by using trig functions. Okay, so I've been given, let's see, this is my distance, so this is adjacent over opposite, and adjacent and opposite is tangent, so tan of 3 degrees is equal to my opposite over the distance, and we normally put x. Okay, so if I want to solve this problem for the distance from the airplane to the airport, from actually where the airplane is in the sky to the airport, I can cross multiply. So that means if I put a 1 under this, I can cross multiply. So 1 times 3,000 is 3,000, and that's equal to d times tan of 3. Now I need to solve for that d. I need to solve for the distance. That d is connected to the tan of 3 by multiplication. The opposite of multiplication, the opposite of multiplication is division. So I can divide off tan of 3, and what I do to one side I have to do to the other, and put that in my calculator, and I can get the actual distance, and that distance will be 57,243 feet. 0.41 feet that airplane, not inches, I'm going to take one of those away, feet from this point to this point. So from the airplane looking down to the airport, that's a distance of 57,000 feet. And that is angle of elevation and angle of depression. So you need to be careful when you're doing word problems. You need to know that they're equal to each other. So if they give you the angle of depression, it is the same thing as the angle that's actually inside the triangle, the angle of elevation. Good luck.